All right, so now we have the natural base e. So it says the natural base e is irrational. It is defined as follows. As x approaches infinity, with this equation here, 1 plus 1 over x raised to the x power, this kind of looks like our formula that we had from the other day, compounding the finances. So here we see it's x and x, but the bigger this number x becomes, it starts to approach this number here. So E is an approximation of 2.71828182846. And the person who came up with this was Leonard Euler. So Euler is U-E-L-E-R. So he came up with the Euler number himself. And once again, he just plugged in numbers, so 1, 1, 2, 2, 3, 3. And what he noticed is this number got bigger and it approached infinity. The approximation was this small number right here. Okay, so let's go ahead and take this and use a couple of things here. So the first thing we're going to talk about is how to simplify expressions using this natural base here. So what we could use here is just pretty much the properties of exponents. To simplify these expressions. So when you are multiplying like bases, if you recall, so e to the third times e to the sixth, the bases are the same. You just add the exponents. So 3 plus 6 is 9. So e to the ninth. Division. When you are dividing big numbers, these coefficients, you divide. So 16 divided by 4 is 4. If the bases are the same, e, 5 and 4, you subtract it. So 5 minus 4 is 1. So I don't need to put e to the first. It's just e. And then when you have a power to a power, you distribute it. So this has a 1. So 3 times 1 is 3 squared. E to the 2 times negative 4x is negative 8x. 3 squared is 9. E to the negative 8x. And hopefully you recall from prior knowledge that we don't like negative exponents. So to simplify this completely without negative exponents, the 9 has a power of 1, which is positive, so that stays on the top. But e and its exponent is negative. It moves to the bottom, and that makes it 8x. So that was a lot of work to get there, but that's what it looks like.